What's up, brothers and sisters? It's your brother G World 7_D, and I got my encyclopedia, my Compton encyclopedia. This is one from the 90s, so I'm going to open it up real quick. I'm going to turn to page 28. I want to first say that the American education system really has failed us, man. Because I'm hearing certain people make the most asinine statements and straight up the dumbest things you can hear. Now, here it is right here. The moving earth. All right, I'm going to read this real quick. And I'm gonna flash like I usually do, flash on something that really I want to really emphasize. The world's rotation and revolution means nearly the same thing, but in describing the Earth's movements, each word is used for a different kind of motion. Revolution refers to the motion of the Earth in its yearly orbit around the Sun. Rotation refers to the spinning of the Earth around its own axis each day. In its revolution around the Sun, the Earth moves in a slightly elliptical orbit at its closest point, called the perihelion. The Earth is 2% closer to the Sun than its average distance from the Sun. This is in the 90s. At its furthest point, it is 2% away than its average distance from the Sun. Now, the Earth motion and the seasons. The Earth's revolution around the Sun accounts for the changes of the seasons. Let me show you this right here. The Earth and the motions and the seasons. The Earth's revolutions around the Sun accounts for the changes of the seasons. The seasons have nothing to do with the Earth's distance from the Sun. Instead, they result from the fact that the Earth's axis of rotation is slightly tipped compared to the plane of its orbit. The Earth's axis is not perpendicular to the plane of its orbit, not straight up and down, but tilts away from the perpendicular plane 23.45 degrees. Although the Earth moves almost in a circle around the Sun, the North Pole always points to the same direction in space. As a result, at one time of the year, winter in the northern hemisphere, the North Pole is tilted away from the Sun. 6 months later, summer in the northern hemisphere, the North Pole is tilted towards the Sun. The reason that the Earth's axis of rotation remains constant is that the Earth is actually a huge gyroscope. All right. Let me get a good. And here's you see image of the Earth. All right. The tilt of the Earth's axis, which always remains at the same angle, causes the seasons by varying the amounts of heat and light that can reach the hemisphere. So it has to rotate. No flat Earth can do that. All right, when you hear people talking about flat Earth, part of our change of seasons because the Earth rotates around the Sun and it rotates in its axis. That flat Earth stuff is nonsense because the flat Earth will not give you those different seasons that we get. Don't listen to them bozos tell you about some goddamn flat Earth, man. It makes no sense. All right, I'm gonna go further down right here. The Earth's motion and weather. The Earth's rotation is responsible for the weather patterns. The atmosphere receives energy from the Sun for its constant movement. Warm air near the equator expands and rises, and the air near the poles cools and sinks. If the Earth were not rotating, let me get back into focus. The circulation might be rather simple. There would be a steadyly wind from the north in the northern hemisphere and a steady south wind in the southern hemisphere. These generally prevailing wind currents are also distributed by cyclones, large swirling masses of air that rotate like huge eddies in the atmosphere. Concentrated cyclones in the Atlantic Ocean are called hurricanes. Those that occur in the Pacific Ocean are called typhoons. The rotation of the Earth affects cyclones by means of an apparent process called the Coriolis effect. The Coriolis effect causes a deflection in the motion of any object moving on or near the Earth's surface. In the northern hemisphere, in the Earth's lower latitudes, about 30 degrees from the equator, the air near the Earth's surface starts its journey by moving down from high altitudes and heading for the equator. The Coriolis effect bends the motion of the southward moving wind to the west to create the winds that move from east, the trade winds. In the northern hemisphere, the higher latitudes between about 40 degrees and 65 degrees from the equator, the air near the Earth's surface also starts its journey by moving down from high altitudes and heading for the pole. The Coriolis effect bends the motion of the northward moving wind to the east to create the winds that move from the west. The prevailing waterlies in the southern hemisphere, the same phenomena occur, but in the opposite direction. Low pressure areas may develop. They act like huge vacuum cleaners, sucking air in from all directions. Sometimes the low pressure effect and the Coriolis effect combined in the swirling motion can become so violent that a great storm, such as a hurricane, develop. All right. And I'm going to read this little last part. The Earth motion and the magnetic field. Many scientists believe that the rotation of the Earth may be a factor in creating the Earth's magnetic field. From the study of seismic waves, scientists have deduced that the Earth's core is molten. They also reason that it must be made of heavy substance, such as iron. It also seems possible that large, slow-moving eddies of molten iron are swirling in the core. This characteristic of the core results from a combination of the heat being generated in the Earth's interior by radioactive elements and the rotation of the Earth. If this theory is correct, it could account for the Earth's magnetic field. The swirling eddies of molten iron in the core will act somewhat like an electromagnet and could create the magnetic field. And here's like the Earth going around the sun. Now, I'm gonna say this, man. Don't listen to these clowns tell you that the Earth is flat. Okay, don't, because you want to have these different seasons, man. And now the Earth is spinning off its axis around the sun. Man, we had these different seasons. Now we just hit spring. Now you're gonna start seeing grass coming by, grass that is brown in the wintertime start to become green because it had its position towards the sun. Leaves start coming on trees. You see bushes with the leaves die during the wintertime. Now you're gonna see the green come out. The green bushes, the green leaves and trees, the green grass. All this starting to be regenerated, reborn, flowers, plants. That has a lot to do from the photosynthesis, but also the rotation of the Earth, man. The different seasons, the changing of the seasons. So these fools tell you that the Earth is flat. That's wrong. All right, don't listen to that, please. That is terrible information. That is butt awful bad information. And this is why we really need to do research and really do our study. I have a book that talks about the Earth. And hold up, and I'm gonna get it real quick. This is something that this is a source I'm gonna give you. 1 second, because we can't do this, man. We can't sit there, continue to be fools, and listen to these goofball clowns tell you about the Earth is flat. Here's a good book that I have called The Origin of the earth and the moon. All right. As well as my what's that book I had? I think I'm gonna say the source. This is about the origin of the earth and moon. You know, and it talks about how the earth and the moon were created. All right. I'm just gonna show you the book a little bit, but this is what you call a serious academic book. All right. With his academic terms, it's one of these academic books, but it tells you about the earth, how it was created, the moon, how the moon was created, the earth's core. It talks about that, you know. So, but this is a good book that you can read if you want to read. I may talk about the earth some more, and I'm going to use this book as my little reference. But I just want to show you this right now about the earth. But this is a good source, the origin of the earth and the moon. This is an academic book. I believe it's by the University of Arizona. Yeah. So this is by the University of Arizona. University of Arizona. So, but this is an exceptional book. It's the back of the book. All right. So I just want to say that, brothers and sisters, give you something to talk about, that the earth is not flat. Yeah, nonsense, man. That's nonsense. All right. The earth is not flat. All right. Peace and love.